12. What is the electron geometry of C2H2? So first let's write out its Lewis structure. And in doing so, we need to calculate the total number of valence electrons. So carbon contains 4 valence electrons, and there are 2 carbon atoms, so we multiply this by 2. Hydrogen contains 1 valence electron, and we also multiply this by 2. Give us a total of 10 valence electrons in C2H2. So now let's draw our 2 carbon atoms bonded together, and then each of these carbons will contain 1 single bonded hydrogen. So now if we look at our carbon atoms, you'll see that they don't have a full octet yet. So we know that these 2 carbon atoms will be triple bonded. And we can double check and count out how many electrons I've drawn in the structure. Each bond contains 2 bonding electrons. So we have 10 electrons in this Lewis structure, so we know that it is correct. So now let's analyze this Lewis structure and look at one of the central carbon atoms. And you can see that both of the carbon atoms have 0 lone pairs. And each carbon atom has 2 bonded atoms. If we look at the VSEPR chart, we can see that if we have 0 lone pairs and 2 bonded atoms, this means that we have a linear molecular shape. The carbons are sp hybridized, and the bond angles are 180 degrees. So you can kind of already see here how these bond angles are 180 degrees. Yep, and electron geometry is also linear. So linear molecular shape and electron geometry. Okay, so the junior tutor said that to determine the molecular geometry of C2H2, also known as ethine, we did need to determine first its Lewis structure. In order to find the Lewis structure, we need to determine the total valence electrons participating in the bond formation. So they got 10. And after finding the total valence electrons, pick the least electronegative atom, and that would be the central atom. So this is an exception where the least electronegative atom is hydrogen, but since hydrogen can only form 1 bond, then we know that carbon would be our central atom. And then finally complete the total valence electrons by placing lone pairs on atoms with an incomplete octet. So we didn't need to do that because we just formed a triple bond between the carbons. Carbon atoms have 2 electron bonding groups, which correspond to a bent structure. So this solution is incorrect. Central, or the carbon atoms, contain 0 lone pairs and 2 bonded atoms each. Therefore, the molecular geometry and electron geometry would be linear. Okay, so I think the junior tutor corresponded it to a bent structure. If we were to have 2 bonded atoms and 1 lone pair, then indeed we would get a molecular shape that is bent. But since the carbons don't have any lone pairs, then we just have a linear molecular geometry.